Prerequisite skills for pre-calculus. Skill number 1B, set builder notation. Let's start with some symbols. The script R represents the real numbers. The script Z represents the integers because the German word for digit, Ziffer, begins with a Z. The rational numbers are represented by script Q. The complex numbers are represented by a script C. The natural numbers, which are the positive integers, so 1, 2, 3, etc., are represented by a script N. The imaginary numbers are represented by a script I. If we have a set with no solution, i.e. an empty set or null set, we use this symbol. A lot of the time when you're using set builder notation, you're making a list, and that list might have some condition on it. So we need to have a condition, and a lot of time we use the symbol element of or contained in to help us explain that condition. Similarly, we need the such that symbol in the curly brackets to separate our formula from any information that we need to tell the reader about that formula. Sometimes set builder notation is as simple as just removing values from a list. In that case, we use the excluding symbol. As you saw in interval notation, the U represents the union, or the word or. In statistics and probability, you'll see that the upside down U means intersection or and. So or is a U, and is the upside down U. Let's consider some examples. In this case, we've used interval notation to represent all the numbers, real numbers, less than but not equal to negative 17, greater than or but not equal to negative 17 and less than 0, greater than 0 and less than 9, and greater than 9. So really what we're looking at is the real number line where we've excluded three values, negative 17, 0, and 9. So set builder notation would allow us to say you have the set of all real numbers, excluding, and then we're excluding a list. So we use curly brackets for that list, negative 17, 0, and 9. So all real numbers excluding negative 17, 0, and 9 is the same as this interval notation up above. In this case, we have an infinite list. That's what the symbols and the ends tell us. And that it is the multiples of 5. So negative 10, negative 5. How do we represent this? Well, any multiple of 5 is really an integer times 5. So if n is an integer, then 5 times n would be a value in this list. It would be a multiple of 5. Now, if we just say our set is curly bracket 5n, the reader will then ask, well, what does n represent? Is n a real number? Is n an integer? Is n a complex number? Is n an imaginary number? So we need to be specific. We need to specify that n is an element of or belongs in the set of all integers. Now we're ready to write our set builder notation. So we write curly bracket, 5n, such that, that's what the vertical line tells us, n is an element of the integers. And then we close our curly bracket. So it's a list because of the curly brackets. We have a formula defining that list, and then we have an explanation for the variable in that formula. Here's a similar problem. Again, it's an infinite list, but now these are the odd numbers. Now the odd numbers are closely associated with the even numbers. If this was a list of even numbers, we would say, well, an even number is an integer multiplied by 2. We would need to specify that that was an integer. So we would say the even integers are represented by curly bracket 2n such that n is an element of the integers. For an odd number, well, any odd number is either one more or one less than an even number. So 2n plus 1 would be an even number plus 1. 2n minus 1 would also be an even number, in this case minus 1. In each case, that would be an odd number. So we can say that our list here is represented by curly bracket, our formula, 2n plus 1, such that, and now we have to explain to the reader what n is. N is an element of the integers. We could just as easily do it with the 2n minus 1. Now, building off that, we have the following example. In this case, if we look carefully, we have a pi over 2 in each of these values. It's an infinite list. We have a -3, a -1, a 1, a 3, and a 5. So we can use interval notation or set builder notation. Interval notation wouldn't fit because of the gaps. This is a discrete list. So with set builder, what we notice is that we're really taking an odd number and we're multiplying it by pi over 2. In this case, we want to specify to the reader that n is an integer. So we're going to say that we have curly bracket 2n plus 1, close parentheses, pi, and that parentheses is very important, all over 2, such that n is an element of the integers. Now let's consider a slightly more advanced example. So in this case, we want the list of all the odd numbers greater than -10 and less than 16. Well, one way to do it would be just to list those values. So -9, -7, -5, -3, -1, 1, 3, 5, 7, 9, 11, 13, and 15. And that would be in set builder notation. This is literally a list. But sometimes you say, that's just too long. Can I write a formula for this? Well, these are odd numbers, right? So you would use 2n. In this case, let's use 2n plus 1. All right, now to get the -9, we would use a -5 for the n, right? To get the 15, we would use a 7 for the n. So we're using values of n that are greater than or equal to, in this case we said -5, and less than or equal to 7. But we have to go a step further and say, but those n values have to be integers. And now we're ready to write our set builder notation. We have curly bracket 2n plus 1 such that n is a number between -5 and 7 inclusive, and additionally n must be an integer. And so this represents the list up above. And this concludes our quick review of set builder notation.